Okay, you guys, so now we're moving on with functions, and we're going to use slope-intercept form and standard form, but let's review, because we're working with straight lines. So when a points on a graph lie across a straight line, it's called a linear relation. Linear relations can be expressed by an equation. For example, the equation of this graph could be written as x plus y equals 8. Linear equations are often written in standard form. So standard form is ax plus by equals c, where a, b, and c are integers. A is greater than 1, and the greatest common factor of a, b, and c is 1. So, for example, we need to make the first number positive. So I'm just going to divide everything by a -1 to get this into standard form. So in standard form, it would be 5x. Ooh, that's not a plus. I have white out now. So it'll be minus 6y equals positive 12. For this one, we need to get 2x over this way, so we're going to subtract it over. So now I have negative 2x plus y equals -9. But now my next issue is that negative sign in front of the 2, so let's divide everything by -1, and I get positive 2x minus y equals 9. Let's look at the next one. I notice I don't have anything on this side, and that 24 shouldn't be here, so we're going to add it over. I get 9x plus 6y equals 24. And that's perfect because it's positive, and all the numbers are whole. This one, I'm just going to add the 7x over. So I have 7x plus 7y equals 7. But I've noticed there's all 7s. Why don't we just divide them all out? Because the greatest common factor would just make it all 1. So this would be the better version of it. I wanted to do number 5. First thing I notice is the fractions is an issue. So to get rid of the fractions, I'm going to multiply by the greatest common factor between 4 and 3, which is 12. So 3/4 times 12 is 9x. 1/3 times 12 is 4. Y equals 12. And now it works. And we'll skip the last one. We don't have to go through all of this. So that's standard form, and I feel like that's something we don't remember as much. But slope-intercept form, you guys definitely remember, and we write that as y equals mx plus b. Or if we want it in function form, it's f of x equals mx plus b, where m is the slope, and b is the y-intercept. If you had me in algebra, you'll remember my slope with the skier. It's a constant rate of change, so think rise over run. There are 4 types of slope. So first is positive, and that's when our skier is going uphill from left to right. Then we have negative, where it's going downwards from left to right. We have our little skier dude. Then we have 0, and that's where it's flat, and you know your skier would go 0 miles an hour. And then lastly, undefined, and the way I used to think of it is if my skier fell off a cliff, he would die, so undefined. So make sure to graph that, and then we're going to review graphing in slope-intercept form. And that's why we like slope-intercept form, because it's very easy to graph. So for number 7, they have it in slope-intercept form, where m is 2 over 5, b is 7. So we always start with b. That means go up the y-axis to 7. 1, 2, 3, 4, 5, 6, 7. Put a nice large dot. This slope means go up 2, go right 5. I can't go up 2, right 5, so I'm going to do the opposite. Down 2, left 5. And I can only make the 2 dots, so that would be your line. Let's do one more. Let's do this one because we do have to rearrange this. So notice it's in standard form. We need to get it into slope-intercept form. So I'm going to start by subtracting x over, and I get 3y equals negative x minus 15. I divide everything by 3. I get y equals negative 1/3 x minus 5. So b is negative 5. M is negative 1/3. So let's graph the negative 5 first. So 1, 2, 3, 4, 5. This slope means go down 1, right 3. So down 1, right 3. Down 1, right 3. Like that. And I'm going to connect my line. And boom. I'll give you guys a second to rate that. Alright, so next, vertical and horizontal lines. Here's a vertical line. It goes through the x-axis, so I always write x equals, and then I find where it intersects, which is here. So that's 1, 2, negative 3. Notice this one hits the y-axis, so it's going to be y equals, and it hits it at 1. So that's a reminder on vertical and horizontal lines. The last thing we need to review is parallel and perpendicular lines. Slopes are parallel if the slopes are the same or equal. The slopes of perpendicular lines are negative reciprocals. I used to say opposite reciprocals, but negative reciprocals work. Reciprocal means when we flip the fraction. Let's do 14. Yeah, we'll do 14. So first thing, we need to look at the slopes. This is not in slope-intercept form, so let's change it up. I'm going to subtract 8x over, so I have negative 6y equals negative 8x plus 42. Then I'm going to divide everything by negative 6, and I get y equals, so 8 over 6, it turns positive. I'm going to change it to a 4/3x minus 7. So my slope here is 4/3. We need to find out the next one, so we're going to divide by negative 3. So I get y equals negative 3 plus 4/3. So look, it's the same slope, so that's parallel. And then I think that's it. Let's just stop there.